And I want to share my slide. Let's see which one is it that I want to share now. I don't even know which one. Windows. No. Okay. Can you see my slide? Can you see my screen?
No.
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 Doctor.
Okay.
No, doctor. No, doctor.
Okay, let me see which one I'm sharing. Okay. Share content or the desktop. Let's see. When you see my slide, just let me know.
Yeah, I can see it now.
Can you see now?
Yes, doctor.
Okay.
Yes.
So this statistics, and I want to tell you that the course BIX1004 is divided into two: statistics, basic statistics, as well as spatial data analysis. So in basic statistics, we talk about numbers. In spatial data analysis, you are going to talk about geographic information system and how it affects the real estate industry. So the cost info, I am sure you will have seen it in Spectrum, is divided into two like this. So the first one on the left, on my left side, is the statistics, which will take the first 7 weeks. While the other one from week 8 to the end of the semester will be taken by Sir Abdugani. So before we go on, I want to share, to play this YouTube video for you on statistics. So let's see if we can have an idea of what statistics is from this video. And then I will play it from here. I have the link here, and I'll play it for you so that we just know what we are going to do in this this is a YouTube. Skip. So, yeah.
Sir, is there supposed to be any sound?
Oh, you're not getting the sound?
No.
I have the maximum. Sorry for that. Yeah, sorry for the audio loss, but I think I've put it in the team. You can access it to play it. I play it again. This summarizes what we're going to do in statistics for this semester. So our course outline, looking from that clip we just watched, we talk about descriptive statistics and inferential statistics. Under descriptive, we will talk about the concept of central tendency, frequency distributions, concepts in dispersion, which is variance and standard deviation, as well as concept in position. Under inferential statistics, we are going to look at relationship and association test, which may be correlation, hypothesis testing, which could be t-test, f-test, chi-square, analysis of variance, regression analysis, which is a prediction test. Then we'll now look at the techniques in statistics using SPSS, as well as apply statistics into real estate. So here, if I may ask, what can you say about statistics now from the clip we have just watched and from this brief introduction? So what is your idea of statistics now? Or do I say, what is your idea of statistics before now? So how will you respond? Anybody? What is your idea of statistics?
Collecting data by the numbers. Collecting data by the numbers.
Any other person? Okay. A collection of data in numbers. That's a good try, I would say. So, okay, let's look at our my brief explanation on statistics. So we say statistics is a science that's concerned with collection, organization, you analyze, you store, you interpret, you display, and make a decision out of a data. So statistics go beyond just collecting data or collecting information. It goes on to how you organize it, how it is analyzed, interpretation, and decisions that are made out of the data you have gathered. Useful decisions. So statistics help us to make a prediction, to help us in deciding what will happen or what can happen. So based on the data we have gathered from the known to the unknown, we can predict the unknown. So it is a branch in mathematics which is always about numerical data. So it is numerical data. Statistics deal with numerical data. When we have data that are not in numerical terms, they can be converted through coding, through ranking, to numerical data for easy analysis. Do we understand that? Any question? So if you have any question about that, please ask, or you type in the chat box. When I get back to the chat box, I will look at the questions. Yeah. So we have to understand statistics as a fundamental of social sciences studies programs, which are essential for us. We need to understand that in our everyday activities, there are some things that we do that relate to statistics unknowingly. So the power to interpret the results of statistical analysis depends on how much knowledge. So here what I'm trying to say is this: how much knowledge of statistics do you have will help you in order to be able to predict or to analyze a data. For example, if we are looking at the score of students in a particular subject, we can use it to predict what the score can be in another subject. Or if you have a result of students in a particular semester or some semesters back, you can use it to predict what the score will be in the coming semesters, because the trend of what the performance will give a direction of what is expected to be in the future. So we just need to have a kind of conceptual framework understanding so that we know where and how to apply statistics in our studies and in our daily activities. So basically, since we are dealing with numerical data, it involves a range of data that can be collected over a different subject matter. The clip we just look at shows us about weight, height, but we can get some information about even the crime rates, the prices of goods, and the behaviors of people, as well as the sales. So if you have sales record over the last 10 years, that can be used to predict what the sales will be in the future or in the next 1 year. So these are the power of statistics. It is being used in economy, is behaviors, even in medical science. So having a record of what happens in the past can help us to understand what is likely to happen in the future. In the real estate industry, when you have an idea of the prices of houses or the prices of retail outlets, you will be able to predict and to estimate what will be the prices in the future, or what will be the prices of a different subject matter. For example, in our valuation in real estate, if you know the value of other similar properties, that helps you and guides you to get the value for a subject property to be assessed. So these are elements of statistics. So you get the price, you get the yield, you get the rate of interest, you get the construction cost per meter square. All these are becoming data for you to predict or to value another property. So these are the kind of numerical data we are talking about as far as real estate is concerned. But it goes beyond real estate, that it can involve complex calculations. So however, the modern day high-tech has given us a lot of softwares that can be used to make all these calculations simple. So nobody needs to worry about how long can he make calculations, how many mathematics theorem do you have. There are softwares in the practice that will guide you on what to do. All you need to know is just to know what should be done. Then you put your data inside, and from there, you get your results. So we have different packages for statistics, for social sciences. We have SPSS, we have R+, we have Mathematica. There are a lot of software, but for us, SPSS is what we're going to use in this class, and Excel, Microsoft Excel, because Microsoft Excel is also an econometric software that can do a lot of statistical analysis. So branches of statistics, we have descriptive, which deals with data and their characteristics description. So you look at the data, how many people are of so-so-so height, or how many people are of so-so-so weight, how many of them are female, how many of them are male. These are characteristics of data that we can display. And that is what we do in descriptive statistics. What is the average? How dispersed are the data or the variables are from their averages? So then under inferential statistics, we are going to be predicting the unknown from the known. You use what you have known to predict what you don't know. So, and I say statistical conclusions are applicable to the population and masses and not the individual unpredictable elements. Most times conclusions are drawn from a representative group and they are assumed to be characteristics of the population or the mass. So what I'm trying to say here is this. Most of the time, if I need to study the characteristics or maybe a particular variable or a particular item of all the students in the University of Malaya, or even let's say the students in the Faculty of Built Environment in University of Malaya, it will be difficult for me, it may be difficult for me to get all the students one by one, which will mean I will have to visit the entire population of the students in the Faculty of Built Environment. However, I can do with a sample, select a sample across the various departments, across different levels. And that sample should be representative enough to give me an idea of what the whole population looks like. For instance, if I want to do that, that means in each department and each year, I must select students across each department each year. So from year one in BS, year one in NACI, year one in the real estate, I select students, I select a year two, I select a year three across board. And they must be representative enough. They must be a mixture of the gender. My sample cannot always be a male or female. That will be biased. So it must be cut across the gender, perhaps across the nationalities that are in the class, foreign, local, and all other characteristics. So when my sample cut across all these characteristics, then we call the sample a representative group or a representative sample, meaning that that sample, that few number that I've selected will be a representative of the entire students in the built environment. And that is what we call sample, representative sample. What this means is that this sample will be able to give me an idea of what the entire population I gather from this, gathering this information from the whole students, the whole population of students. Then we go to data and representation. I hope that explanation about sample is clear. Anyone? Is that explanation about sample clear? So we go to data representation. Please let me know if you are okay with that, because today's class is an introductory class. It's more of talking. So we'll look at all these basic principles that we need to know so that we'll be able to apply them when we need to be making calculations. So I want to believe that it's clear. Nobody's responding. It's okay. Thank you.
It's clear, Doctor.
Thank you. So now data and data representation. So when we are setting up to do for statistics, the purpose is to investigate a particular set or a set of challenges or a set of ideas or a set of problems. We want to solve a problem. So we may need to collect data, different data. For example, the data might have to go do with the age, as it might be about the income, about the height, about the education, about status. For example, if we're looking at the relationship between the height and lifespan. So what I mean is that short people live long, or the tall people live longer. You know, we are talking about the height of people and their lifetime. So definitely you will need to get a data that has to do with height and age. So if you have somebody who is short and is 99 years old, and you have somebody who is, majority of tall people are of 70 years old. So you begin to look at why are people of higher height not having age of 100, 120. So this is a kind of relationship. So if you want to know what the height has to do with the lifestyle, there are information we need to gather about the height of people and their ages. So this will dictate whether a short person will live longer or not. Again, if you want to look at a situation like education, the level of education, the level of exposure on income, maybe you see that people who reach up to PhD degree are higher, getting the highest income. That means you look at the education qualification of people. You have to get data of education qualification of people and get the income so that you will be able to relate the two. So then you can even talk about different variables that can be affecting a particular variable. For example, lifespan can be dependent on income, can be dependent on age, can dependent on, no, lifetime can depend on income, can depend on education or some other things, or even race. Oh, people of this race usually live longer. I think there was a time they said the lifespan is in Japan is the highest. So that means Japanese live longer. And if any other people want to live longer, you will want to know what makes Japanese live longer. Is it their diet? Is it because they have more money to spend? Or is it because of the quality education? Or is it because of gene? So all these things comes together. And when we are talking about data, these are data we may not be able to identify the data we need to solve a problem or to make a study or an investigation, so that we'll be able to have a good view of what is happening. So when we talk about lifespan and we say income can affect lifespan, yes. For example, if you have good income, that means you have financial resources for good health and for perhaps a good balanced diet. And that may prolong life. So some people can tell you the diet you are eating give you a long lifespan. So then you check diet. What are the makeup of the diet? What do I need to have? So all these are constituting the data you need for a particular study. So the chart I have here is talking about share of what's gross domestic product, GDP, across the world. So we can say the Middle East, the China, the India, and in West Europe, in USA. So all these are information that can be used in predicting some other things in the future, or to understand what exactly is happening. Because the GDP could have an effect on individuals in a nation. So we can use this GDP to know how poor or how rich individuals of a country is. So because by the time you put your GDP of a country on the population, then we are having the per capita income for individuals in that nation. So from there we can compare to know in which nation there's more prosperity. So this is what data talks. And when we have gathered data in this mode, there are different ways of representing those data. And this is what we go in the next slide. So here, if from this introduction, let's look at what are the keywords that we have mentioned. We have mentioned about variables or data. We have mentioned about case. We need to mention about the responses. So what here, I'm trying to identify the keywords that can come up in statistics from as we go on. Items of interest. That means whatever you want to study is what we call variable. So you want to, all these variables we want to collect. For example, the last slide, I talk about age, income, education. All these are variables that can affect another variable. So these are items of interest in statistics. When we have to get a data from individual items or individual person, for example, when I said I want to study the student in built environment. So each respondent, each student that is ready to respond to my survey or to my questionnaires, or it's ready to give me the data I wanted, for such as their age, their income, their tribe, and their races. So we call them a case. That means that is a case. Why the responses gotten from all these cases are called observation. So these are key terms that can come up in statistics. So you should know what a case is, what variables are, and what we regarded as observation. So data are therefore a collection of observations. When you now talk about the large data, you have collected a lot of information about from observations. When the observations have been collected from a group of respondents, then it is called a data set. So if I've gotten the information I requested from the students in built environment, then I call the entire thing a data set. So data set is what I begin to manipulate, analyze, present to people. So again, you will have been hearing about variables. I talk about variable now. We will about hearing about type of variables, dependent and independent variables. When we talk about dependent variable, we are talking about a variable that is depending on the other. For example, age is depending on diet. If you eat very well, you will live long. If you eat junks, you may die young. So we are saying age is now depending on diet. So age is now a dependent variable, while diet is now a predictor, because what you eat determines your age. So it is the diet that is determining your age. So diet can predict age. So this is an idea of a simplest way of explaining dependent and independent variable. Another way I can explain this is, for example, as students, what determines our CGPA or our grade? Let's put it as a grade. Who have first class, second class, upper, second class, lower. What determines it? Our CGPA. How do we arrive at CGPA? That means our performances in different courses that we have been taught, our understanding of different courses. So CGPA will be dependent on student performances. And what are the student performances that it determines your test, how you do in assignment, how you do in exam. So these are three key things that determines your grade in each subject. And accumulation of all these subjects determines your grade as a graduate. So our grade will become a dependent variable. Then independent variables that are predicting that dependent variables, our performances in different assessments. Okay, I think I have information here. Is anyone trying to join this class that have not been added before? Please let me quickly check. I just want to know if anybody is trying to join. Okay, no request. So we can go on. So then we have what they call continuous variable. Continuous variable in the sense that by their measurement, they go on. They don't stop. You measure, it goes on and on and on. And what we have another one we call discrete. Discrete means there are some, just as in the small video we watch, there are some figures that you cannot get. For example, when you are counting people, you can't count 1.5 people. You can't say you have 3.5 people. It's either there are 2 or there are 3. There's no half person. There's no 1/4 person. But there are some variables that can be measured they can take any form of unit. Like height, you can take 6.3 meter, 4 meter, 4.1 meter. So these are the different things we will see. Now, I want us to quickly look at data type and measurements as I've been describing through this chart. So we have variables. Variable can also be called as a data, because whatever you are getting it, we are getting the data for that particular variable. So you have qualitative, we have quantitative. I'm sure you are familiar with qualitative and quantitative now. Quantitative is measured in numeric terms, while qualitatives are being measured in ranking style, nominal or ordinal. So either you rank or you make them categorical, because they cannot be expressed in numbers. For example, age. When you say, no, sorry, gender. When you say male, female, how do you measure male? How do you measure female? So such is a qualitative data that can be transformed into a quantitative data through ranking or through giving nominal number or ordinal numbers. So the types, we can, when we look at the quantitative data, we can have discrete, we can have continuous. Continuous in the sense that it continues, it takes any form. Then we have qualitative, we have non-numerical, qualitative and non-numerical, as I've explained. So you can get it in nominal or ordinal. So here, data are also, depending on their sources, categorized as primary data or secondary data. Secondary in the sense that somebody has collected it, you just access an archive to bring them out for further analysis. While primary data are the data collected by the investigator, by the researcher himself, so that all these data will be processed further. So these are ways of data, the types of data in, or the type of classification of variables. We have dependent, we have non-dependent. That is depending on their type of measurement. When depending on their function, either they are dependent, we want to predict them, or something is predicting them. So then we have quantitative, qualitative. Quantity because it is numerical. Quality because it is non-numerical. Then we can also classify data based on their source. That's why we sell primary source, secondary source. And this is reflected in when you are doing your academic project. You should be able to distinguish between dependent variable and independent variable. Also, you should be able to know what are primary data and what are secondary data. Do I make that one clear as well? Do I make it clear as well?
Yes, doctor.
Good. So, data type and measurement. Let's quickly look at data type and measurement. So, we have said that some data are ranked, their ordinal measurements are ranked, and we have said some are categorical. So when we look at this slide, if you are seeing the slide very well, so we look at the ranking level of some data when we want to rank ordinal data, because that is what you want to measure. We use what we call Likert scale of measurement, and the ranking could be either is it important, is agreeing, the level of agreement, either it is important, efficient, or whatever. Then you are looking at whether you are against, whether you are in support. If you are against, you give you 1. For example, let's look at important. That means very unimportant is given as 1. You are disagreeing with the point that it is important. Even if you are using efficient or you are using adequate or level of agreement, because this is determining your level of agreement to a particular statement. If I say it is important to attend classes so as to make good grades, you know, what I'm looking at, class, your agreement to the level of attending classes. So if you said unimportant, then it can be ranked 1 because you are totally against. If you are saying your level of support is low level of agreement, you can give 2. If you are not sure, indifference, 3. If you are in support, that, oh, you agree to the statement that attending classes hate performance, you can give 4. If your level of support is higher, we can give 5. So such is an arrangement that you can give a Likert scale of assessment. And if you have been trying Google survey, if you put anything on scale, the Google survey will allow you to define the scale from what to what. If you say from 1 to 5, you will be able to define what 1 stands for, what 5 stands for. Then the Google survey will give you the grade, the ranking, and people can tick. So this is when it comes to ranking, because I am making more effort on this so that we know that the way we can transfer the non-numerical measurement into numerical measurement. So this is what we do. We give a scale of the level of acceptance. So, but if it is for categorical variables, whatever ranking you have given, no one is greater than the other. In the Likert scale, you can see that 1 is greater than the other, but the only thing is that in between each ranking, the distance is not equal. So you can say the difference between against and low level is the same thing as the difference between support and high level of support. But at least we know that 1 is better than the other. 2 is better than 1. 4 is better than 3. 5 is better than 4. But in the categorical variables, they are equal. They are only being separated with figures. For example, gender, male, female. There's no measurement that will tell you that male is greater than female or female is greater than male. Even if female is having a score of 2 or a rank of 2, it doesn't mean the female is higher than the male. Also, if you are ranking race, if you are adopting race, it doesn't mean that one race is superior to the other or not. For example, we can say white, which is having 1, is less than Black Africa of 3, because the Black Africa carry 3. It doesn't mean it's greater than white. It doesn't mean it's greater than Black America. It doesn't mean it's greater or lower than Asia. So it's just a number to be able to assess and do mathematical manipulation so that calculations can be done on them. So either category, when they are categorical, is saying that 1 is not greater than the other. However, when it is an ordinal measurement, there is no unequal interval between each measurement. It's the only thing is that 1 is better than the other, but on unequal interval. So that is what the data measurement tells us. So if we want to present our data, data can be presented in table form. In a table form like this. So if you want to represent an information, you can use tables. And when you are using tables, that means we are counting their frequency. And when we count frequency, we will be able to know what happens. So let's look at these tables that I have here. Table 1 is talking about the best subject of students of real estate in UM. So let's assume this class is representing the UM. So what is your best subject? So can anyone tell me? Okay, let me ask you the question now. Your best subject. So Anyone? As a real estate student, tell me your best subject. So, statistics. Okay, somebody says statistics, right? Any other person? I'm counting. Statistics, 1.
Special valuation.
Okay, valuation. Okay. Valuation 1, statistics 1.
Relative finance.
What?
Finance.
Science, finance. Okay.
Yeah.
Okay, real estate finance. Okay. So I want to see how the spread will be in this class so that we'll know what subject is the most, because we want to represent the data and know what the subject is. Okay, type. If you don't want to speak, type. I will count. How many people want law valuation? How many people want law of statistics? How many people are in finance? How many people are in property law? So, or property management. So which subject is your best? I did response. Okay, valuation 2, finance 1, okay, statistics 1. So let's give our process, please type, and we'll quickly count and represent it in a table now. Can we? Okay, valuation law, yes. Valuation. So it means a lot of people in this class love valuation, because valuation is carrying the day. Yes, valuation, valuation, valuation. Okay. The rate at which we are having valuation shows that majority in this class love valuation more than any other course, right? So if that is the case, I will tell you, so there's no way you will do away without statistics, because statistics is about mathematical or figure manipulations. And that is because if you're in valuation, when you are doing mass valuation, there are some predictions. There are models for mass valuation, and the models for mass valuation were developed from statistics principles. Is that clear? So back on my slide. Now back on my slide, the best subject of students of real estate in I have 8 valuations, property management 11. This is not your own survey. This is a personal survey. 4 peak statistics, 7 peak real estate finance, and 7 peak land economics. So with this representation, you will see that the highest number by frequency is property management. So that means 11 out of 37 says they love property management. When you see the relationship between real estate finance and land economics, you will see the tally, and even valuation. So they are not too far away from each other. So that means in this, I'm talking about this table now, that means the distribution is somehow uneven. It's not specifically saying that majority love one or the other. That means that class is diverse. That class is diverse. We have reasonable number of people who love valuation, reasonable number of people who love real estate finance. So the conclusion I can make here is that the students of real estate in love statistics less, because that is the only one that is far away from others. So we will try to say that statistics is their least subject. However, when we look at table 2, table 2 talk about the best subject of male and female students in real estate. So the reason why I do table 2 is to show how many of those people who said they love valuation are male, how many are female. So it's a way of breaking down the components so that we will know how many female love valuation and how many male love statistics. You can see from the distribution, this is just hypothetical. The distribution shows that in every subject, the number of males are higher. However, that may not be the reality. This is just an hypothetical case. But this, I'm just using this to inform you on how much information you can get with a particular reference to whatever you are investigating. Table 1 is talking about how many students, the best subject of each of the students. We look at it, then we can look at these subjects, how many of them are preferred by male, how many are preferred by female. We can even go ahead and know how many are preferred by races. Oh, international students love valuation because valuation is global. Once they know the valuation theory, they can apply it anywhere in the world. So they prefer valuation. Or the local students want valuation because they want to be global, or because they want to be sure that their experience can help them in any show. Or there might be different reasons. You know, in real estate, there are some businesses or some activities that are regulated by the law. So the local law dictates. It's different from a subject that is having the same principle across the world. So, for example, statistics. Statistics is to be applied to every situation. So it has the same principle all over the world. Real estate finance, however, the financing system in each locality or in each nation is determined by the law of the land. If the law says you cannot charge more than this as interest, so when you are talking about real estate financing, you can make references to local laws, but there's no local law affecting statistics. So when you are talking about property management, there could be local laws that you need to observe some things, but the general principle is there. So these are the ways that you can probe the subject of interest, or what are the things that can affect the love of the subject you have chosen. So in real estate, if you know statistics very well, good. If you know real estate finance very well, fine. You must know the general principle very, very well. Then the peculiar situation of each country has to be taken into consideration. So these are the things that can make differences on who and what do they like most, especially in real estate. Real estate is a diverse program, so it covers a lot of things. So that by the time you begin to make specialization, you know where do you want to belong to. So from the simple survey we have done in the class now, we can see that people love valuation. However, I want to say that, do you know valuation is regulated locally too? Especially when we are talking about land acquisition and compensation. So each nation has a law that guides public land acquisition, and the law specify how the valuation for compensation will be made, what principle. So different laws, especially our land laws, affect valuation in the area of compensation. Also, when you are doing insurance valuation, there could be each country has their law guiding insurance principles. So each country has their law guiding property investment. So you should be able to know what the law says about insurance valuation in the country. What are the law of insurance, principles of insurance? What are the things that are peculiar to that country so that it will be reflected in your valuation? So, but also when you come to sales of properties, for example, you need to know the law that has to do with the tax laws, as also as the registration of your title, registration of transactions. These laws are local laws that differentiate what happened in one country to the other. So these are the informations that can be gathered and be used when you are doing any investigation. Is that clear?
Yes.
So I have somebody here that loves urban planning practice. Yes. So, but urban planning too, or planning generally, has to be affected by the local law because we have town planning laws. We have development control regulations. So all those things have to be, if you are laying out how much green area you have to give, what is the occupation ratio, building ratio to the land, building land ratio. So all this has to be known. And that is why you see in some areas, you will see much more land, much more green area and a small property, not too big property. And in some area, you will see all the development, intense development, because the law allows it. So all those things has to do with the local law. So if you want to be an urban planner practice now, definitely you will want to know more of the law of the land in Malaysia, how it regulates planning and development. So if you want to take that to another country, you have to study the law of that country concerning development as well. So this is the differences in what subjects and what courses do you like. You want to go global, you want to be local. If you want to go global as a planner, that means you study a lot of laws of planning of the different countries so that you can speak authoritatively what happens anywhere because you are informed. So this is an interest. So, and this is an extra mile work for different choice. I hope I'm okay with that. So I look at my table 3 here, the students of according to races and faculty institutes. So look at this. Oh, we want to know how many students are international, how many are this. I give others as international students, then other races, you can see the way I've distributed these. So these are just hypothetical. They are not based, they are not real life figures, but we just try to make an example of what are the data, what are the information that can be gathered. So, and what can they be used for? And mostly in statistics or in statistics or in academic projects later on, when you have an statistical information to be displayed, the source must be added. So where did you get your source from? So that we'll know whether the data you are presenting is genuine and reliable. So if it is something you have collected by yourself through your primary data collection, then you can say field work and you put the year, the date, the year, and possibly the month of collection of those information so that it will serve as a source that you collected this information by yourself. If it is taken from somewhere, you sized the source as the source of the data you are presenting. So, also, data can be presented in form of graphs. So it can be a bar chart, it can be a pie chart, it can be a line graph. So when you are presenting the data in this format, you should be able to tell us how the data looks like. So for example, if you look at the bar chart, it gives an idea of what transpires. So how many students, the students in Alambina by race, you can look at it. So one is not, all these figures you're having here, they are hypothetical. They are not real life conducted. So you look at this, you can say, oh, from here, one can quickly see, oh, this is the spread. And this is an information. So anybody can rely on this and say, oh, students in Alambida are more of this tribe or not, or this race or not. Then when you look at the pie chart, you know, from the bar chart, you can easily see which one is greater. Even on the pie chart, you can see which one look bigger, and there are some areas you can get confused which one is bigger here, especially the blue and the green. So the other three, you may not specifically know, no, this is the one that is higher. But it speaks of something. It tells us of something. It's telling us about the distribution of the students in the faculty. Then when you look at the line graph, I use line graph for the other chart, number 3. And you can look at how the figure looks like. So this shows in law what and what in different lines. So we'll know how many of them are in this place, how many of them in this faculty, how many in this faculty. By the time you have the total, then you have which one is bigger in the school. So there are a lot of, all this one that I'm showing you, all these charts here, can be done in Excel, can be done in SPSS, can be done in ArcStat. So all these statistical softwares are available for us these days. We just need to key in our data and all analysis can be done. We need not to be doing this manually anymore. But however, I think it will be good for you to know how to do it. How many people know how to draw a pie chart? Yes? How many know how to do a pie chart?
I think others now.
I know.
Okay. So what's the process like? So a pie chart, I didn't say bar chart. Bar chart is easy. But a pie, you know, you have to take whatever you want to do into, because a circle has 360 degrees.
Yeah.
So you have to convert everything into degrees. Then you begin to mark them out. You draw a circle, put a protractor from the center. You begin to draw. How many degrees belongs to this? 30 degrees, 200 degrees. Okay, I think you are reminded now. So everybody know how to do it manually now. Because these days, because there are softwares, some of us doesn't know how to do it manually. Am I right? Or are we saying everybody in this class can do pie chart manually?
Yes.
We haven't
Okay.
done it in a long time.
It's a long time you have done it, but you can do.
Yeah.
Okay, maybe we will do in exam.
Oh my God.
Will that be good? So that we represent in exam, so we know how perfect you are.
You mean drawing the pie
Yes.
chart during the exam?
Yes.
Oh, that one we don't know.
Okay. At least we have all been using Excel. I know, because I think this class has made some presentations in the past that I've witnessed, right?
Yeah.
And you have used all these tools, charts, pie charts, line diagram to show some data, especially when you were doing your assignment on real estate investment analysis. I could remember, yeah? So there are some representation you will have done, but the only thing is that the theory or the principle behind it need to be known. So we will look at what we can do as we go on. But it is a way of representing data. So when you are doing that, you are representing the data and you are conveying an information to your audience, to those who are reading what you do. Is that right? Is that taken? Okay, so let's look at the next slide here. I think possibly the last slide for this class for today. So let's check basic things we have talked about in this class today. We have talked about statistics, basic statistics. We said cases are individuals in a sample. So when I have a sample of UM students as your class, each one of you become a case in the sample. While the whole class of the BIX1004 class is a sample representing students in Alabina. So when we talk about variables, variables are characteristics of the cases. For example, if I say each student is a case, right? So what are the variables? So let's put that in the context of discussion now. So when I say this class, to me, is a sample representing students in Alabina. Let's assume that's your class. So, and I say each member of this class is a case that I want to study. So what are the characteristics that we need to study on each one of you? Anybody? Can you give me your characteristics?
Clever.
Okay, clever, either you are clever or not. Okay, fine. I will take that.
Height.
Height, good. Your height, your gender, your age, sometimes people take color of hair, your hair, the color. That is if that has to do with whatever analysis you want to do. If it doesn't have anything to do, it may not be of interest. Then we can look at what subject do you like most, because that will be peculiar to each one of you. The subject I like might not be the subject the other person like. So what subject you like most? I can even ask you, what type of food do you like most? You know, these are becoming characteristics of each cases. So I think you understand what characteristics can mean. Every items within which I can define a case become a characteristics. For example, I can say Y is short because I look at your height. So by your characteristics, Mr. Y is short. So all I need to do is to define what I mean by short. Okay, anybody that is less than 4 feet is short. So when I say Mr. Y is short, so Mr. Y is less than 4 feet. That's a characteristics. And I can say Miss B, Mrs. B is tall. That means Mrs. B is taller than 4 feet. So these are characteristics: the height, the color, the races. So if you are international or local, is a characteristic that I can study, because there could be different behavior from a local person, a national here, and an international person, because of cultural differences and orientations. So there are different ways of reacting to issues. So all these are characteristics that I can study on each student to make a general statement. So whatever is coming on frequently among all the cases become a standard. So if everybody is 4 feet, if majority is 4 feet, then I can quickly say everybody in BIX1004 is short. Do you understand that? Because that means majority of people in that class are less than 4 feet in height. So instead of telling people that I have short people, I have tall people in my class, I would say the class is, everybody in the class is short in height. So that's a characteristic. And that height characteristics now will now become the characteristics of the class, of the whole sample, because that is what is common. More people, maybe 90% is less than 4 feet tall. So I can now generalize that people in that class are short people. There are short people in the class. That does not mean there's no single person that is tall. We are talking about sample representing the whole, the population. I hope that is clear. Then we talk about observations. Observation means all responses that I've gathered from every one of you pertaining to the question I've asked. When I put it together, they become observations. Then when I have a full observations of every case, everybody in that class, then I can call it a data set. So then we talk about type of variables. We talk about having qualitative and quantitative variable, or it can be defined in terms of dependent or independent. And I added one that even data can be according to their sources, whether they are primary source or the secondary source. So under here, I have it again, what could be a nominal variable or a nominal data, or what could be ordinal data or ordinal variable. So also interval and ratio data. So then the other slide here is trying to show us that ratio data, we can go from nominal to ordinal to interval to ratio. These are the classes. Now, for ratio and interval, they are for quantitative data. For qualitative data, we have ordinal and nominal data. I think these are basic things you need to know in statistics as an introduction. So you know that we can represent our data by chart, we can represent by table. So this forms the basis of statistics. And that's we end my presentation for today. So we enter into different questions and answer of what we have talked today. Thank you for being in class. So let's have questions sections. Yeah. Questions? So questions time. No question? Or should I be asking question and you'll be answering?
There is no
Yes.
assignment. There is no assignment for this course.
There will be assignment for this course in the part 2. Sagani will give you assignments. Okay?
When is our test?
Yes, you'll when you look at your course info, yeah, my test will come up in week 6. So we will have done much work before week 6. So you'll be having my test in week 6. Then after the test, we will round up the class in week 7 for my section. Okay?
How about the test structure? Will be call us to draw the bar chart or pie chart?
When we get to that cross to the bridge, we will find a way of crossing it. Anyway, the test will be determined by the volume of work we have done before the test date. So the test will be determined by how much work we have been able to do before the test date. because we need to cover up to inferential statistics before we do test. And that is possible in the next 3 weeks. Yes, any other question? So if for the assignment, I think Sagani will put up the notice, and you can also check your spectrum. Check spectrum, so that you see whether you have news about the test. Yes, I have set up an attendance for this class in spectrum.
But doctor, we cannot sign
Yes.
in the attendance. We cannot sign the attendance on Spectrum because it's not open yet, or the settings problem, maybe.
Okay. For settings problem from the university or from me?
I'm not sure because all of us log in the Spectrum, but we can find the attendance, but we cannot sign in.
Okay. Oh, you can find the attendance there. It's only that you cannot sign in. Okay.
Yeah.
Okay. So I begin to pick your attendance from here today until you are able to sign in, right? Will that be good?
Okay. All right. Thank you, doctor.
So I have, how many people do I have in class today? You will sign attendance here now. Okay. 34. I think we are 32 in class, right? Class rep, how many are we? 32? I think. Are we more than that?
We have 36 actually.
We have
in the class.
Yeah. Class. Okay. 30. How many are in class now? 33. Okay, 34. We have 34 in class now. So who are the missing two? So that's why you will sign attendance now. We still have time to do that. So again, so that's about the attendance. When you are able to do it on Spectrum, I would prefer you do it on Spectrum so that you have the record of your attendance there. Okay? So any other question?
I think you need to enable it somehow.
Okay.
Yeah.
I will check. I will check soon now.
All right.
So
Thank you.
I'll look at this if it is from my hand. So I want to stop sharing my slide. So we ask questions. You're still free to ask questions. Okay.
Do we have class on Thursday, this Thursday,
Yes.
for tutorial or continue lecture?
Yes. The tutorial and the lecture for this course is interwoven. During the tutorial, we need to do more of exercises, you know. So when I talk in class, finish. Tutorial, we need to do more of working. So we will be doing it together. Okay? So by Thursday, I intend to go into descriptive statistics. So as we listen to lecture, then we do okay.
So for this course, we only need Microsoft Excel
and SPSS. You all have Microsoft Excel, Abby?
Yes, we have.
We'll do some on Microsoft Excel, like mean, standard deviation. We can even do some correlation, internal rate of, we did internal rate of return the last time. We can still, all those things can be done on Excel, but when we need to do some other tests like chi-square test, F-test, even Excel can do regression when it's not too large, but SPSS is better when you want to be doing all these correlation things, it's better in SPSS. If you do it in Excel, you only do correlation of 1 to 1 and it will give you. But in SPSS, you can correlate 10 items against each other. So we use Excel for simple calculations, SPSS for graphical displays and regression, and test of significance, whether it's significant or not. So I hope by the time you will be doing your academic project, maybe COVID will have gone. So you'll be able to do more of real life research that you will need to use all these principles. Okay?
Doctor, but
Yes.
when we look at the course information, they show we have 2 tests and each is 30 marks. And we don't have any assignment, right?
Each
Yes,
is 20
according to-
marks. Oh, each is 20 marks, right?
Each one is
Yes.
30.
Yes, I'm having the thing with me. And perhaps because of the COVID, that means you will not have assignment. Since normally assignment for this course is about spatial analysis. Okay? So there will be no assignment if that is and the problem will have been because of the COVID. Because you won't be able to go outside to go and do something. You know, lecture for this semester is basically online.
Oh, so meaning we don't need to do any assignments like our seniors.
That is the implication, that you will not do assignment.
Okay, all right, thank you, Doctor.
Yeah. So that's good. But there will be 2 tests. Okay. So, how far with the introduction to statistics? Any problem? Or you are good? Everything is okay?
I think it's okay so far.
Okay. So you can still study it at a time. So, but I think it should be okay. So let me, yes.
So for statistics, we just need to know how to key in the statistic into the Excel, or we need to really learn about like the internal rate of return, how it this work, how internal rate of return work.
Yes, the internal rate of return is it has its own calculation on its own from the evaluation approach, where you do net present value and you are looking for a rate that will give you NPV to equal 0. Remember. So, but instead of doing trial and error, changing the rate of return or the yield, changing the yield until you get the one that gives you 0, or instead of doing 2 NPV and try to apply the formula, you know, there's a formula for that, and do that, the Excel can just pick your data and work it out for you. That is just the difference. You remember I thought, oh, it's not your class. There's a class I taught how to do solver in Excel. So you give some commands. I think when next semester, when you are doing the property development, we'll come back to internal rate of return again, and I can teach you solver, how to use solver to get your internal rate of return. Okay? So I think we can do that, and in property development, but also Excel can just give you an idea of your internal rate of return. So I'm trying regular, yes. Any other question? Any other question?
No, doctor, no question.
Okay, I'm checking the attendance. It's not restricted from my end. No restriction. So maybe it's still the problem we have with the system.
I'm not sure because with the other lecturers' classes, that particular class will be enabled and we can submit our attendance. Here, all of it, we can't click on any of it.
So yes, I'm trying to check. As I am now, I'm on Spectrum.
Mm-hmm.
I'm trying to see the setting.
Yeah.
There's no restriction from my hand here because I'm trying to see if I can edit the setting. Okay.
Okay.
Okay. So attendance is shown. Duplicate assign rates, delays, move rights. So there's no restriction from my hand. So I'm trying to look at it if there's any other thing so that if it is from here, so I can release it so that you can be able to sign up your attendance, but no restriction. Okay, for today, let's take the attendance from theme for today. At least I have 35 participants plus me, making 34 students, right? So everybody use mark present in the chat box. Yeah. There's no option to submit attendance, okay? I've seen this. Okay, what is SPSS? SPSS is statistical package for social scientists. So it's just a package, it's just an application for social sciences to manipulate things. So yeah, yes, someone has, attendance has started. 180021 has marked present. Everybody mark your attendance present. Okay, go on. There's no option to submit. Okay. Yes. Okay. Yes. That's nice. Everybody should mark attendance, please. Yes, continue. I'm counting here because this will be our attendance for today. Feel free to ask any other question.
So, doctor, is it the end of this class?
Yes, once the attendance is marked and there's no more question, we can end the class. So if you have signed your attendance and there's no more question, you can leave. It's 12:42 now.
Okay, thank you, Dr. Olan.
Thank
All right,
you.
thank you, doctor.
Thank you.
Thank you, doctor.
Thank you.
Thank you, doctor.
My
Thank you,
pleasure.
doctor.
Thank you.